Welcome to all. Now today we are going to discuss about the chemistry of the coordination compounds. In this lecture, just we have to look into the brief view of the coordination compounds. What are the coordination compounds and how we can nomenclature, how we can um, write the name of these coordination compounds. The nomenclature we can see in the next portion. So start with the what is meant by the coordination compound. So what are the coordination compounds? What do you think about the transition metal binding to the other atoms? And then we call them the coordination compounds. So there are the transition metal ions. The transition metal ions, they are bind in such these. This is the coordination compounds when they are binding to the other atom, and the structure is like a complex in nature. So that type of structure is called as a complex. According to the Werner theory, the central metal atom can bond to a group of the molecules or ions that is called as the metal ions. Means there is one central metal. This central metal atom is attached to the other atoms. So this central metal atom is called as metal complex. The compounds containing complexes are coordination compounds. Next. The molecules or ions coordinating to the metal are called as ligands. They are usually anions or polar molecules. They must have lone pairs of the interact with the metal. Means these metal ion here the metal ion is also central metal atom is a cobalt, and the metal atom is attached with the another atom. For example, here the cobalt ion is attached to the Cl ion. So Cl is called as a ligand. Similarly, the cobalt atom is also attached with here is nitrogen atom, and it contains a hydrogen atom, right? That is an NH3 group. So that's why the this amine group is called as a ligand. So that's why the molecules or ions coordinating to the metal atom, that ions or molecules is called as a ligands. That is shown in this picture. This is one of the examples of the ligands which all the ligands contains lone pairs of the electrons. Look at here. For water molecule, there is oxygen contain lone pair. For nitrogen, there is a lone pair. Chlorine is a lone pair. Carbon is a lone pair. Nitrogen is a lone pair. So such type of molecules or ions which have lone pair is called as ligands. So according to this organic magnetic compound, the Werner is proposed the first theory in 1983 that, and according to him, there when the complex is formed, there is a two types of valencies that is called as a primary valency and secondary valency. The primary valence is equal to the metal's oxidation number, and the second valency is the number of atoms directly bonded to the metal atom. That is also called as a coordination number. Keep in mind, the oxidation number and coordination number is a different one. So these, what is meant by the oxidation number and what is meant by the coordination number, we will see in the next slide. This is the oxidation numbers. So if we are considered this complex, that is the tetraamino copper 2 plus, this is a complex. If in this complex the copper is a metal atom, is a metal, and the NH3 group which is attached to the copper is directly attached. That's why it is called as a amine group is directly called as it is attached with the copper. So that's why it is called as ligand, and the central metal atom is a copper here. This square bracket is called as a coordination sphere. Out of this coordination sphere, there is a charge plus 2. So that's why this is a ionic complex. Okay. So if we can calculate, if we have calculate oxidation number, then just write this is, we have to calculate the oxidation number of this metal atom, that is copper. So that's why first we have to write the oxidation. First we have to calculate the number of electrons associated with the amine group. So we know that amine is a neutral atom. So that's why the total number of amine group is attached to the copper atom is 4. That's why here written is a 4. NH3 group is a neutral atom. That's why we are written here is a 0 is equal to, this is coordination sphere. Out of this coordination sphere there is only plus 2 charge. That's why we are written here the plus 2. If we, in case of copper, we have written here only x. So that is x plus 4 into 0 is equal to plus 2. That's why x is equal to plus 2. That's why here written here the x value is plus 2. And x value is plus 2 is nothing but the oxidation number of a copper is plus 2, right? Next, what is meant by the oxidation number? Let us calculate the oxidation number of this molecule. Here is the central metal atom is chromium. Okay, water and chlorine. This chromium is a metal. To this metal, the water molecule and the chlorine molecule is directly attached. So that's why first we have to calculate the oxidation number of this chromium atom. Here the water molecule is a 4, and we know that the water, the nature of the water ligand is a neutral ligand. That's why we have written here is 0. And how many number of H2O molecules are associated with the chromium atom? 4. That's why here written is a 4 into 0. So instead of 3 we have to write here x plus 4 into 0 plus chlorine molecule. One chlorine molecule contains minus 1 charge, and here how many number of chlorine atoms is present? 2. Yes, that's why we are written is a 2 into minus 1, that is equal to, out of coordination sphere there is a no charge, that's why written is a plus 1. So the oxidation state of the chromium is a plus 3. Next, 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 next. So thank you very much.